Alright, so this video is showing us the 25 pin terminal block used for the Compact Logic PLCs. So this terminal block has two rows of terminals. So there's two rows of terminals with 25 pins on the top row and 25 pins on the bottom row. And these have all been pre-wired then into the PLC. So what we see right here is that the very first pin, so this first pin down here is a 24 volt coming from the power supply of the PLC, and this is ground. The next five are for DC inputs. So these are 24 volt digital DC inputs. The next two are DC outputs, 24 volt DC outputs. The next five are for relays, so we have a voltage and then 4 outputs for the relays. And then this large block of 10, which are pins 15 through 25, are where we wire the analog inputs and outputs. So if we look here, there's included on your sheet is the wirings for the pins. So pin 1 is 24 volts, pin 2 is ground, and then pin 15, 16, and 17 are for channel 0, analog in. So if you want to use current, you would have current go into 17 and it would be coming out of 16. For channel 1, current would go into channel 19 and come out of pin 18. So looking at the terminal block a little bit closer on the back side here, you see that all 25 pins on the back side are already wired. So you do not want to change the back side of the wirings for these lower pins. Do not change that. There's 2 resistors coming up here to the first two. These are you don't want to mess with anything that's already pre-wired. Do not remove or loosen any terminals that are already pre-wired. Okay. But the top, you see the whole top row here, these are actually available, so we can use these for extra wiring as needed. Alright, you also notice here the DIN rail where the terminal blocks are attached to extends out. This extends out further so that we can connect in a IMA converter. So we have 2 Red Lion control converters here, and when you first look at them, they look very, very similar. However, you notice that this one has a square block, a square white block in the center of it with a big CE here, and then it only has a few dip switches over here to the left of it. Alright, this is for counting frequency. We will not be using that for this lab here, so make sure when you get your controller converters, you select the correct ones. This is an IFMA converter. This is an IAMA converter. So you want to make sure that you get the IAMA converter. That's the one we're going to be using. Alright, when you look at it, you see the wiring on here. You can power this thing. If you look, you can power this thing with a voltage anywhere between 11 to 36 volts DC, or even plus or minus, even 24 volts AC. So when you look at this, it gives you the pin layout here. The DC plus, this is where you would put your positive voltage. and then your negative voltage would be on pin 2. Now those pins are here at the top, and you put in, so the wire would go in the top. Right here, the wire would go in the top, and then you would tighten the screw down. So, but before you do that, and before you apply power to these, you need to set your dip switches. So this is a converter, and it can output a lot of different analog signals. The one we're going to use is a 4 to 20 milliamp. So switches 3, 4, and 5 need to be set to 0, 1, 1. And then we're going to be using 50 millivolts. So we come down here and we find 0 to 50 millivolts, and we find that that is all zeros. For 6 through 9 is zeros, and 10 is a 1. So if you look at these dip switches, you see we have 0, 0. The first two are just set to 0, and then 0, 1, 1. 0, 1, 1 here, and then we have 4 zeros and a 1. So that's how we set the dip switches. You need to make sure you get the dip switches set correctly. Do not change the dip switches with power applied. Once you've got your dip switches set, have the instructor verify, and you can begin wiring them up. Alright, so this is we're going to be using 2 load cells. So this is a terminal block already wired. So you see that we have these converters. These converters, you just can clip them right on here, and they'll snap right on there and hold in place. So I've got the 2 converters here, and I've got them wired up for load cells. And so I've set my dip switches. Now to power these things need voltage. We're going to get the voltage to power these from the 24 volts right here that's being provided from the PLC. So we're going to have 24 volts and ground. And what I'm using is I'm wiring that up to this top, to a top unused block terminal. So I'm wiring the 24 volts up to an unused one, and then the ground up to an unused one, so that I can then wire that, and I'm going to wire those into to power these controllers. Now, when you're wiring these, so when you're going to wire these, you need to take the wire. Number one, don't use really big 16 gauge kind of thick wire. You just need to use some thin wire, 20 to 22 gauge wire. And so I'm going to wire these. These are my positive wires. These are the positive wires coming from my block, from my converters, from my red line converters. And so what I'm going to do to wire these, I'm going to put just 2 wires. Never try to put more than 2 wires into the terminal. And I'm going to twist the wire together a little bit before I put it in there. That way it will help hold them together and keep them from slipping out. So twist them together a little bit, and then I'm going to put them in here, and I'm just going to tighten that down. Now, you don't have to tighten these real tight. Just make sure that the wires don't pull out. If you over tighten them, you'll damage the terminals. There's no need to crank down on these really hard. It's not like we're putting tires on a semi or even a car. We just start putting these little wires inside of these little terminals. So I'm going to wire that. That one slipped out. Wire that back in there. Okay. So I have my 24 volts. Okay. So I have my 24 volts coming up from the bottom front of the terminal into the spare terminal on top, and I got my positive 24 volts. I got two wires in there, one going to the converter on the left and the other going over to the converter on the right. And then the same with the ground wire, so that these will be powered when I plug the terminal into the PLC. Okay. I then have my the blue wire. There's a blue wire right here and a white wire coming in here. Those are going to be my current ends into my PLC. So those blue and white wires are wired down in here into pin 16 and 15 and pin 20 and 19. Alright, so those are wired in to the bottom here, wired up. That's where my 4 to 20 milliamp signals are going to be coming in. Alright, so we've got our load cell. Our load cell has 4 wires on it. So our load cell here, our load cell has 4 wires, a red and a black wire, and then a green and a white wire. Now notice you don't have a lot of room here on these wires. Do not try to strip these wires any more than what they are. They just have a little bit of room here. What we're going to do is we're going to use these terminals. So you see I've got my load cell here. I just got those 4 wires wired up there. So here's my load cell, and I've got it wired in here so that we have the red and the black, the green and the white, okay, into the top unused set of terminals there. And then the same for the second load cell. I'm just using another set, red, black, green, and white. Don't try to spread these all apart. They won't reach. Okay, so keep them right together and keep them in order. Then on the back side of our terminal block, so if we come look at the back side of the terminal block there, we're coming out, I need 10 volts. So I'm going to have my load cell, or I'm going to have my power supply. I set my power supply to 10 volts, and I've set it with my meter up here. Okay, I don't have the meter hooked up right now, but I've already set this to 10 volts, and I shut power off before attaching the wires. But now when I connect these wires in here, okay, here's my load cell. I've got the 10 volts wired in to this terminal, and then it's also jumping. I'm going to jump it over here to the other terminal for the other load cell. Remember, load cells can only have about 10 or a maximum of 12 volts in them, so we can't use the 24 volts supplied by the converter. So I'm just going to take this. I've got my 1 wire coming in from the power supply, and then I'm going to jumper it over here so I can run the 2 load cells. So here is load cell 1 coming in to this terminal, and it come through here, and this wire then is going over into the power supply. And then this wire is jumped over here, so I've got 10 volts here and I've got 10 volts here. I also have my ground wire coming in from the power supply, and then I have it jumpered over. And then I have the green and the whites connected to the green and the white and wired into the converter for the settings for 50 millivolts. Okay. So when you look at this, this is all tied in here, very nice and neat. So we have our power supply. We have our 24 volt power supply over here on the left, which is going to power our 2 black Redline IAMA converters. These converters are going to take the 50 millivolt signal from the load cell and convert that into a milliamp signal to go into the PLC. I have the load cell, I have the 4 wires of the load cell wired into the top set of terminals, and then I'm powering with the red and the black wires on the top, and then I'm running the green and the white over to the converters. And the wiring is on your diagram, and your pin numbers are on there. So you can connect this up. So then the 4 to 20 milliamp is coming out of the blue, and the white return. The white is the return, so the blue is bringing in 20 milliamps, which is going to go into the analog channel of the PLC, and then it's a current, so of course it has to come back out. It comes back out the white and returns into the converter. So once we have that all set up, we're going to take our load cells, and we have these stands for our load cells. We're going to take our load cells, set them in the stands, and we have this bar. Okay, so we're creating a weighing system here. And so what we're going to do is we're going to take the load cells, and we want to set these bars. We want the load cells set to the very edge. Kind of hard to do and hold the camera. Okay, so we're going to take our load cell, and set at the very edge of the bars, and we're going to find the center of the bar and mark the center of the bar. If you look, there's probably already a mark on there. This bar has really got all kinds of marks on it. But we want to measure the exact center of the bar. Okay, so here's my little weigh system. So I have a load cell on each side. So there's a load cell on each side of this bar. And now what I'm going to do is I'm going to take my weight, and I'm going to set the weight in the center. So I need to measure the center of my bar, and I'm going to set the weight on top of there. So when we measure, we're going to have to scale. We're going to have to do scaling to figure out the actual weighs, because there's weight on this bar for one, and we can't include that. So we've got to find out what is our input from the load cells with just the bar in, and that's with no load. Right? The bar is just part of the scale system. It's not something we're trying to weigh. And then we'll take our weight and we'll put our test weight on there to get our weight, and then we can do our scaling. Now, if this is a 5-pound weight, it's supposed to be a 5-pound weight, so that would mean half of the weight is going to be on the left load cell, and half of the weight is going to be on the right load cell. So we need to split. So if it was 5 pounds, there would be 2.5 pounds on the left, and then 2.5 pounds on the right. Okay. However, this weight isn't exactly 5 pounds. You can see on there I've got this marked, it's 4.79 pounds. So it's not quite 5 pounds. So what I need to do is divide 4.79 in half and use that as my weight for the left and the right load cell when I'm trying to calculate my scaling.